Hello and welcome to today's lesson. We're going to be talking about compound inequalities. So these are inequalities that are separated by the word and or, and we're going to be looking at how to solve and graph them and work with them in word problems. And we're also going to be looking at inequalities that have absolute values in them and how to solve them also. So there's going to be pretty similar to solving equations, but there's going to be a few extra tricks or steps that you have to remember. So make sure that you're taking notes so you have those written down to refer back to when you are trying these problems on your own. And remember, you can always pause at the beginning of any question and try that question yourself, making sure to list all of your steps and writing everything that you do down, and then pressing play, and then you can compare what I did to what you wrote, and you can find out what you're doing really great and maybe some areas that you still need to work on and study. And it'll help pinpoint those areas so that you are not wasting your time studying things you already know. So I'm so glad that you can join us today, and let's go ahead and take some notes.
There are two types of compound inequalities. And a compound inequality means you have two or more inequalities that are separated by the word and or the word or. So an and inequality represents the intersection of a graph of inequalities. So that means where, if you graph them on the number line, where those graphs overlap. And typically it's going to be between two numbers. So a graph of an and compound inequality is going to be between 2 points like this. And there's two ways that you can write an and inequality. You can write it as the first inequality, the word and the second inequality. Or the shorter, more common way is the lower number less than variable less than bigger number. Or you could have less than equal to's here, but you're not going to have greater than. The other type is a compound inequality where the inequalities are separated by the word or. This represents the union of graphs of inequalities. So that means they're not going to overlap. The graphs are going to be going in separate directions. And this is always written with the word or. We don't shorten it at all. Just as a reminder on how we graph the different inequalities, remember that if there's an equal to part, you're going to use a closed dot. And if there's just the greater than and just the less than, you're going to use the open dot. Remember, for greater than and equal to and greater than, you're going to shade up towards the bigger numbers. And if for the less than, equal to, and the less than, you're going to shade down towards the smaller numbers. So just a quick refresher for when we start graphing two or more of these. So steps for solving compound inequalities. The first thing is you're going to want to separate the problem as two inequalities. So if they've rewritten the and inequality the short way that I showed you, just go ahead and rewrite it as two separate ones. And then you're going to solve each problem, and then you're going to graph the answer in a number line to get your complete solution. We're also going to see some compound inequalities that have absolute values in them also. And this is going to follow very similarly to absolute value equations if you've watched that video. So the steps here is you get that absolute value by itself on one side of the inequality, just like you did with equations. Then you're going to simplify within the absolute value bars, just like you did with equations. And then you're going to split the absolute value into two cases, one for each sign, just like you did with equations. And then you solve each of the two cases for the variable. Remember, don't forget this part or you're going to get every answer wrong, is that your solving inequalities is exactly like solving equations, except when you multiply or divide by a negative number, then you have to remember to switch that inequality. An example, greater than switches to less than. And then just like I said before, when you're graphing, you use an open circle for less than and greater than, and use the closed circle when it has the equal to part. So greater than or equal to, less than or equal to. Or if you're graphing just an equal, that's just a dot on the number. So right now I have an and inequality. And like we said in the steps, you can separate this into two separate inequalities, or you can remember that you're working three parts. And so I'll show you what working those three parts would look like. And that just saves a little bit of time and space. But if that confuses you, just break it into two problems. So if you broke it into one problem, you'd have the 60 less than negative 6 times the quantity x minus 4. And then you would have the problem negative 6 times the quantity x minus 4 is less than 120. So those would be your two problems. So you would just rewrite them separately and solve them. So the first thing I want to do is get rid of the parentheses. So I'm going to just distribute the negative 6 in that middle part. And that's going to be negative 6x plus 24. Negative 6 times minus 4 is a positive 24. And then I still have the less than 120 at the end, and the 60 less than at the beginning. And so now I'm going to solve this middle part for x. And whatever I do to the middle part, I have to do to the beginning and the end. So I'm going to be doing it 3 times, one for each part. And the first thing I'm going to do is subtract 24. So I subtract 24 from 120, and I subtract 24 from 60. So 60 minus 24 is 36. And then I have my less than symbol. Here the 24's cancel, and I'm just left with the negative 6x less than. And then 120 minus 24 is 96. And so I'm going to continue to get this x by itself. So I'm going to need to divide negative 6 by all 3 pieces. And remember, when you divide or multiply a negative number by an absolute in an inequality, that's going to flip the inequality sign. So these less thans are now going to become greater thans. So 36 divided by negative 6 is negative 6. Here these negative 6 cancel, and I'm just left with x. And then 96 divided by negative 6 is negative 16. And so that's going to be my answer, but an and inequality is always written the smaller number, which here is negative 16, with a less than x less than the bigger number, negative 6. So that's why you see that it's been flipped, which is allowable because you flipped everything in this problem. So it's still going to be true. And that's why your final answer here is C. Now we're going to look at an inequality that has an absolute value in it. So our first step is to get this absolute value isolated. So that means we need to move the 2 and the 6. We're going to start with the minus 6, just like if you were solving an equation. So you're going to add 6 to both sides. That's going to leave us with 2 times the absolute value of 3x plus 7. These 6's cancel, is less than 14. And then we're going to divide both sides by 2. These 2's cancel. These numbers are locked in absolute value prison, so you don't divide them by 2. And then that's going to leave us with the absolute value of 3x plus 7 is less than 7. And now I have that absolute values isolated. I can't simplify within it. So I'm going to go ahead and do the split. So that means I'm going to drop the absolute value signs. I'm going to have 3x plus 7 is less than 7. And then I'm also going to have 3x plus 7. And here, this is where it's a little different than the equation. You flip the inequality also. So this less than is going to become a greater than. And then I change the sign to the answer. So instead of positive 7, I'm going to change it to negative 7.
And these are going to be my two inequalities that I solve. So starting with the first one, I'm going to subtract 7 from both sides. These 7's cancel. So I'm left with 3x is less than 0. And then I'm going to divide both sides by 3. These 3's cancel. And I'm left with x is less than 0 divided by 3, or 0 out of 3 is just 0. So x is less than 0 is my first answer. And then I just repeat that with the second one. Subtract 7 from both sides. It's going to be 3x is greater than negative 14. And then divide both sides by 3. And that gives me x is greater than negative 14 thirds is my two answers. So now I see that I have two answers, A and D, that have negative 14 thirds and 0 in them. And so I just have to decide, is this an or answer or an and answer? And the easiest way for me to do that is to just make a little number line. It doesn't have to be anything fancy. I'm just going to put the two numbers on it that are my answers in order, of course. So the negative number goes first and then 0. So x is less than 0 is going to be an open circle with shading down. And then x is greater than negative 14 thirds. It's going to be an open circle and shaded up. So I can see that there's a part where they overlap. And this is going to be my answer. And since it's an intersection, that makes it an and, which makes D my final answer. Here I'm being asked to show my answer as in graphic form. So instead of it being x is greater than or less than a number and x is greater than or less than a number, it's just giving you the graph. So we can go ahead and do that. We're going to want to get this absolute value isolated first, though. So that means I'm going to have to divide both sides by positive 3. These 3's will cancel. Once again, x minus 3 is an absolute value of JL, so they don't get divided by 3. So that's going to be the absolute value of x minus 3 is greater than or equal to 1. And then I go ahead and do my split. It's going to be x minus 3 is less than or equal to positive 1. And then x minus 3, I flip the inequality and change the sign, so less than or equal to negative 1. And then I just solve each of these separately. I'm going to add 3 to both sides. And here that's going to give me x is greater than or equal to 4. And I do the same with my second equation. I add 3 to both sides. And that gives me x is less than or equal to 2. And so those are my two answers. And so now I have to decide what that graph is going to look like. So I'm just going to go ahead and do a sketch of a graph where I'm going to put 2 and 4 in the correct places on a number line. And 2 is going to be and closed dot where I shade down for less than. And then I'm going to be on 4 is going to be a closed dot again where I shade up for greater than. So now I'm just looking for the graph that looks similar to that, and that's B, my final answer. In this problem, they give us what we typically see as the answer as the question and ask us to match the problem to the answer. So to do that, we're just going to try out each one of these choices and see which one matches, gives us the correct answer. So in all of these, the absolute value is already isolated, so that makes it a bit of a shorter problem for us. So in A, I just need to take x is less than 1. Just go ahead and start with that split. And then I'm also going to have x is less than or equal to negative 1. And then I'm going to go ahead and graph that. Just like I said, just do a sketch of a graph where you put the negative 1 and the positive 1. So negative 1 is less than or equal to. So I'm going to put a closed dot and shade down. and positive 1 is greater than or equal to, so I'm going to put a closed dot and shade up. And that one actually works out to be the answer that we're looking for, which is choice A. And if you're ever not sure, you would want to check all of these to make sure that you didn't make a silly mistake and that these all actually are different from the answer that you're given in the question. Here's another type of problem that gives us an OR inequality, and I just need to solve each of these OR inequalities separately for x. So all I did here was just rewrite the problem over here where I could work it out easier. And I'm going to go ahead and subtract 4 from both sides. These 4's cancel, and that just leaves me with positive 4x is less than or equal to negative 12. Then I'm going to divide both sides by 4. And that leaves me with x is less than or equal to negative 3. And then I just go ahead and do the same thing with the second one. I'm going to add 3 to both sides. That's going to give 5x is greater than 15. Then I go ahead and divide both sides by 5. These 5's are going to cancel out. That leaves me with x is greater than 3. So I'm looking for a graph that has a closed circle at negative 3, since it has the equal to part. So I'm looking at the negative 3's, and these have open circles at negative 3, so that can't be my answer. Next, I'm looking for a open circle at positive 3, which these both have also. So now I need to look at the direction of the shading. So at negative 3, that's a less than, so I'm going to shade down towards the smaller numbers. So negative 3, here this one is shading down. And then at positive 3, I need to be shading up towards the bigger numbers. And B also shades up towards the bigger numbers. So that means B is going to be my final answer. This next problem, they already have the inequality all solved for us. It's an and inequality, and we're just matching that this and compounds inequality to which graph. So at negative 6, it's a greater than, so that means I need to have an open circle at negative 6. So I'm looking at negative 6, and the only two with open circles are A and D. So that means B and C can't be my answer, so I'm going to cross them off. Okay, it's a greater than negative 6, so that means I'm going to be shading up. So here at negative 6, it's going up. Here at negative 6, it's going down. That means D isn't going to be my answer either. Now let's go ahead and check the second part with A, just to make sure I didn't make a silly mistake. So it's a less than or equal to, so that means I'm going to have a closed dot at positive 1. And I'm going to shade down because it's less than, so I need smaller numbers. And this one also shades down. And because it's an and, I'm just shading where they intersect, which is why you don't see it beyond 6 or beyond 1, which is what A does. So that means A is going to be my final answer. Okay, this problem says Nick makes pizza at his job. He asked to make the pizza accurate to within 3/10 of an inch of the pan. If the diameter of the pan is X, which inequality shows the diameter Y that Mick can make the pizza? So let's go ahead and draw a picture that shows us what this looks like. So there's my pizza, and I know that this has a diameter of X. And his pizza can only come in within 3/10 of the edge of the pan. So that means it has to be between 3/10 and the edge of the pan. So it could be 2/10, it could be 1/10. It just can't be bigger than 3/10. So the pizza's not big enough. And you don't want to be gypped when you're getting your pizza from a shop. So what would the diameter of the pizza, they also tell us, is Y. So we'll just add that to the picture. So which one of these equalities would make sense? So here, if I take the diameter of the entire pan, which is x, and subtract that from the diameter of the pizza, that's going to be this little spot here that's left. And that's what has to be 3/10 or less. So it's going to be less than or equal to that 3/10, which is a decimal is 0.3. And because this measurement has to be a positive number, I'm going to add the absolute value symbols to that, and that's going to be my answer, which is choice A. This problem says Eve knits scarves for her online store. This week she has already knitted 9 scarves. There are 10 days left in the work week. She set a goal for herself to knit at least 17 scarves, and at the most 19 scarves this week. Eve wants to know how many scarves she should knit each day to meet her goal. So here, let's go ahead and define X and then as the number of scarves she has to knit per day. Now we know that she has to have 17, 18, or 19. It's 17 between 19. To show between with an inequality, you use an and inequality. So it's going to be 2 less than symbols, and then we can have 17 scarves, and she can have 19 scarves, so we add the equal to part. So it tells us in the problem she has 2 days left, and she's already knitted 9 scarves. So that means in her 2 days, her total is, for each day, is x. So to find for 2 days, you would take 2 times x. However, that total scarf she has left to do, she's already done 9 of them, so we can go ahead and subtract that off. And so that's how you could write algebraically what that problem represents, which this matches A, so it's going to be my final answer. So this problem says Amy is planning the seating arrangement for her wedding reception. Each round table can sit 10 guests. The head table can sit the bride and groom with 6 wedding attendants. If Amy expects between 176 to 256 guests to attend her wedding, including the attendants, what is the range for the number of round tables she will need for her reception? So this problem here, I have to write the inequality that represents the problem, and then I have to solve it also. So I know that the number of guests is between 176 and 256. So to show between, we use an and inequality, and we use less than symbols. And since we can have 176, we'll use the equal to part also. And since we can have 256, we'll use the equal to part also at the end. And so then we just need to figure out how to represent the number of tables, which is what X represents. So each table can hold 10 guests. So that means to find the total number of guests seated at tables, we're going to take 10 times the number of tables, or 10 times X. However, we also know that the head table sits the bride and groom with 6 wedding attendants. So since the bride and groom don't count as guests at their own wedding, we are only dealing with that number 6. So we're going to have the guests that are sitting at the round tables that hold 10, plus the 6 more attendants to get the total number of guests. And that's going to be the inequality we solve. So remember, when you have 3 parts of the inequality and an and inequality, whatever I do to the middle, I also have to do the and. So I'm doing it 3 times. So I'm going to subtract 6, and that's going to leave me with 170 is less than or equal to 10x, and it's less than or equal to 250. And you divide by 10 to all 3 places, all 3 parts, And here that's going to leave me with 17 is less than or equal to x is less than or equal to 25, which is going to be our answer. So that means that she's going to need between 17 to 25 round tables for her wedding. Thank you for joining us today, and I hope you learned something new.